Okay, today we're going to talk about aim 1 of the grant. And the situation is we propose that IL17 and 21 act synergistically and directly on germinal center B cells in BXD2 mice to cause autoantibodies through upregulation of somatic hypermutation, class switch, and upregulation of AID, and also BCL6. Now, here's the thing. First off, you get the background. Well, there is no background for IL21 other than acting on B cells other than what we showed. And, Chutao also showed that IL17 also upregulates BCL6 in germinal center B cells, actually in MZP, marginal zone precursors, but not FO and MZ. And he has some data showing it also increases IL21 and RGS16 and AICDA. We have to check IL21. That's our data. So BCL6 is already a target now of IL17. Now, more recently, actually only recently, about a year ago, Tarlington and Venusa showed that IL21 also acts directly on germinal center B cells to upregulate BCL6. We knew before IL21 promoted TFH, and that of course depended on BCL6. And then it also and IL21 from TFH promoted germinal center B cells. But maybe the new thing is IL21 directly upregulates BCL6 in germinal center B cells. And so then you look at the experimental results of what they did. What it appears to do is IL21, let's go over here for Vanessa's conclusion, just as an overview. IL21 on a germinal center B cells increases AICDA, that's what he proposes. It increases BCL6. It holds the B cell back, and also it holds the B cell back so it can undergo successive somatic hypermutation. And it also fosters the interactions of this with TFH and FDCs. That's what he proposes, but look at some of the data here. First off, Tarlington's paper is pretty good. He showed that IL21 upregulated BCL6 in germinal center B cells. One thing is to look at germinal center chimeras, mixed bone marrow chimeras, so you can look at B cell development side by side. Here you need the IL21 receptor knockout. What was done by Tarlington is he put in IL21 receptor knockout in competent B cells. IL21 receptor positive ones were developed slower, but actually by day 7 they developed the same, but actually they were maintained, and then they stayed longer. They seemed to develop slower, so I think there's a slower kinetics, but they turned into long-lived plasmablasts. Whereas the IL21 receptor knockout B cells came out, they exited earlier, they were faster, but maybe they were short-lived because there's a contraction later, and they don't have as much somatic hypermutation. Here, somatic hypermutation data is very good because if you look at just the wild type versus IL21 knockout, where is that? Oh, here. The somatic hypermutation was 5 in the wild type compared to 1. This is some unit, but somatic hypermutation was 5 times normal, 5 times as high if you had IL21. Another thing is location of the B cells. In the wild type, they tend to, this is in mixed chimeras. Well, no, this was actually just immunized with sheep red blood cells or NPCGG. They tend to stay in the germinal center versus in the 21 knockout, they went to the mantle zone on day 14, and then they sort of dissipated by day 28. And Tarlington says in the data not shown, using CXCR4 as a marker, there was no difference between centroblasts and centrocytes. So that's not like it limited the development of centroblasts and centrocytes or the other way around. One might expect them to be different. They would develop, they would proliferate and then rush out. But he says there's no difference in the ratio, but that's data not shown. So that's something to look at. And as I said, Venusa showed the similar thing with sheep red blood cell and immunization. So this shows that IL21 almost seems like it does the same thing as IL17. They both upregulate BCL6, they both promote activation of cytidine deaminase, and they both keep the B cells in a germinal center. So let's look at the model here. In the dark zone, especially in the light zone, we think IL17, that's our data, acts as a glue, and this is RGS13 and 16 related glue to keep the cells in place. IL21 also acts as some kind of a glue, maybe through the same mechanism. But they hold the germinal center in place, and so that intensifies the reaction and get higher SHM. Now, how does this work out to an experimental design? In aim 1, therefore, we want to look at functional synergy between IL-17 and 21 and show that IL-21 and 17 act together to act directly on the germinal center B cells in BXD2 mice to produce SHM, AID, and autoantibodies. So there's certain experiments that are obvious. One is just immunize these mice with NPCGG, B6, BXD2 that are competent, BXD2 IL21 knockout, BXD2 IL17 receptor knockout, and show that the last two strains of mice do have decreased BCL6, it's obviously the case, decreased AID, decreased SHM, and so forth. And maybe the 21 knockout should have relatively normal at day 7, but we don't know because we've got to look at B6 IL21 knockout, I guess, at day 7, but they'll start to be defective in later time points. And then, of course, given this, the IL-21 deficient mice add back with an add IL-21 like we're getting from that guy in Germany, add IL-17 or both, and immunize and see if that corrects in both mice. So we underexpress and overexpress, always the same thing, and see if BCL6, AID, SHM, CSR goes up or down. And then how does IL-17 and 21 act together, and what are the kinetics when you add one or the other or both? Because, as I said in the model, they seem to do the same thing. Okay, that's the whole mouse. Then you do, the second aim would be the mixed bone marrow chimeras, just like Tarlington and Vanessa did. But now we use BXD2 and BXD2 IL-21 receptor knockout. We got to get these mice. We're getting them and crossing them from, the other lab over there, Alan Zajac. But we don't have them yet. And put them on a marker, and then we're going to do the mixed bone marrow chimeras into BXD2 wild type. And actually, IL-17 receptor should be here because that's the IL-17 receptor knockout, and maybe both knockout. Anyway, and put those into wild type bone marrow chimeras and see how which B cells finally come out and produce autoantibodies. So then in this case, if you do it, they're going to have autoantibody producing B cells. And also you could immunize with NPCGG. So we get that. So that's a nice bone marrow chimera experiment. You sort, we did it before, and you do the ELISA spots. That's a bone marrow chimeras. The next thing is, look, probably confocal. We like confocal. You get some confocal pictures anyway. Let's make this 3. This is confocal. Looking at morphology. And we have to look at where the IL-17 receptor ones and IL-21 receptor ones are. But the thing is what happens is without these glue here, they fly out and become in the mantle zone on day 7 or 14. And I believe that will happen either without IL-21, that's what the papers show, and we would suggest that it would probably happen without IL-17. So they're staying out here. And finally, probably as a second aim, but maybe towards the end, we'll look at the combined effect on BCL6. We think that both together would increase BCL6 more. So this is the model. The key thing is, now it appears that IL-17 and IL-21 really are synergistic, and they both upregulate BCL6, they both upregulate AID, SHM, and class switch, probably in the light zone. They both intensify the germinal center reaction. So in fact, the one problem will be to try to figure out how they're different. We do have the model that they're not really different. IL-17 upregulates P50 and promotes IL-21 signaling. So it could be that, in fact, even though the signaling pathways are different, they both act to increase BCL6, and that's the synergistic relationship. BCL6 drives high levels of BCL6 drives everything, and that'll get aim 2 is how to modulate BCL6. So that's all for aim 1. Functional studies.